This is the video 1 of the sound lab. In this video I will explain what we're going to do in the first activity, and I will show how to collect the data, and I will collect some data, then you will have that data to do the analysis and the graphs. In this activity we're going to find the relation between sound intensity as a function of distance to the sound sensor or the detector from the sound source. Okay, here I have the speaker, that is my sound source or sound generator, and this is my sound detector, which is Pasco sound sensor. And you can see here, this is the detector right here. This is the sound detector. Now I have to drive this speaker. I'm going to drive this speaker using Pasco 850 universal interface. So this is the signal generator of the inbuilt signal generator of the 850 universal interface. So you can see these wires which are going to the speaker, they are connected to the output of the 850 universal interface signal generator. So we can generate a signal and we can put that into the speaker, so we can generate signals with different frequencies and different amplitudes. In this experiment I'm going to use 256 Hz sine wave with 3 volt amplitude, and this is the detector, and I can change the distance to the detector from the sound source speaker by sliding this arrangement over this track. So I can position the sound detector at different location on the different position on the track. All right, so in order to control the 850 universal interface to generate sound, I need to open the Pasco Capstan software. So type here Pasco, and this is the software. Now in order to collect data, first I need to connect this sound sensor to the 850 universal interface. I'm going to connect this to analog input A. Also I need to connect this sound sensor virtually to the 850 universal interface. So to do that, go to the hardware setup and open the hardware setup and go to the analog input A, and right click, then search for the sound sensor, and here we have the sound sensor. Now it is connected, and that's all we need to do in the hardware setup. So click on the hardware setup one more time to close this window. Now go to the signal generator. Now you can see all the controls of the signal generator. Now here I'm going to use sine signal, so you can select all the different kind of signals here. So I'm going to use sine signal, and here I can change the frequency of the signal. So go here and type the desired frequency. I'm going to use 256 Hertz, and amplitude of the signal is let's keep it like 3 volt, and if you turn this on, now you can hear you can hear the speaker. And let me actually change the frequency, and you will realize it from different sounds you will hear from the speaker. So I'm just changing the frequency here, and then you will hear different sounds. Okay, let's use 256. I'm going to turn this thing off for now. Now we want to measure sound intensity as a function of distance. To do that, I'm going to get oscilloscope. Here I have oscilloscope. In this menu, I'm going to get that oscilloscope. And then in the oscilloscope, I'm going to see sound intensity as a function of time. Also, I need the signal generator so I can control the signal. And I need a data table to record my data. Sound sensor is 3 centimeters away from the speaker. Now I'm going to turn on the signal generator. Now you can hear that sound, and this is the signal detected by the sound sensor. Now I want to measure the amplitude of this signal. You know what is the amplitude? So I want the height from here to here. From this position, 0 position, to this is the amplitude. So to get the amplitude, what I'm going to do is I'm going to get this bottom value and the top value and get the difference, and if I divide that difference by 2, then I will get the amplitude of the signal. To do that, I have this data table, so I can record the top value, bottom value, the distance, that is the distance from the speaker to the detector, sound sensor, and finally sound intensity. Okay, so I'm going to get this. So let's stop this. Now I have captured the signal, and I'm going to turn off this. Alright, so I captured the signal and I turn off this signal generator. So I have the captured signal. Now I'm going to measure the amplitude of the signal. To do that, let's go here and get this show data coordinate and access delta tool. Click on that and go to this position, that is the bottom value. The bottom value is minus 6.293 minus 6.293, and the top value is, so click on that tool one more time, and the top value here, that is 6.875. So when I enter that, I get the sound intensity, which is this minus this. That will give the difference between these two. When I divide that by 2, you get the sound intensity. The distance is 0.0. Okay, now I have my first data point. I'm going to move this sensor to a 5 centimeter position. Now this is 5 centimeters away from the speaker, and turn on the signal generator. I have the signal and record the signal. Now I have the new signal, and stop recording data. Now I captured the signal, turn off the signal generator. Now use these tools to get the top and bottom value again. The top value is 4.238. The bottom value is minus 3.925. The sound intensity is 4.08, and the distance is minus 0.05 meters or 5 centimeters. Okay, the sound sensor is 10 centimeters away from the speaker. So I'm going to record the third data point. Turn on the signal generator and start monitoring, and you have the new signal. So I'm going to adjust the axes so I can easily get the top and bottom value. Now stop recording data, and now I captured the signal. Now you can turn off the signal generator. Alright, so now let's measure the top and bottom value. The top value is 1.914 and the bottom value is minus 1.723, and then you get the intensity, and the distance is 0.1 meters. So similarly, I'm going to get all the values, all the sound intensity values for different distances up to about 70 or 80 centimeters. Alright, now I have all the data I need to plot the graph between sound intensity versus distance. I have all the sound intensities for sound sensor 3 centimeters away from the speaker to 100 centimeters or 1 meters away from the speaker.